In this debate, I'm going to show the difference between the flat earth and the globe earth. The flat earth shows demonstrations. All of our claims, we show examples and we show real world demonstrations. They ask for numbers and equations which they cannot demonstrate. So the equations are worthless. The numbers are worthless if you can't demonstrate it in real life. For example, when we show long distance observations or mirror flashes or lasers that would be impossible on a globe, they give us 7/6R or some other math in different equations. When we ask them to demonstrate it in real life, they give us sugar water in a fish tank. So when they try to demonstrate it, it literally shows obstruction or limits vision backing up a flat earth. It's ridiculous. So in my opener, I'm going to show a few of them said examples. And I would ask my opponent to give us real world demonstrations of any of your claims and not just mathematics. We don't care about the mathematics until you can show it working in reality. So if you can't show it working in real life, it's just hot air. It's just an excuse. It's not an explanation until you can show it. So I'm going to ask MC TOON to table the math for a minute, show us real world examples of anything ever. This is a short video. I put together a bunch of random jet trails to show that it's not earth curve, it's perspective, making us see in a dome like in our background. So basically our visual background is domed or curved. It's curved in appearance the further away you get. Like that plane there is flying almost straight at us, but it looks like it's going straight up because it's far away. So the further they are away, the more they appear to be going straight up and straight down. When they get closer to us, like that one there, you see that it's level. So as it approaches, it levels out and then starts dropping down as it goes away from us. And it can't be earth curve because let's say that plane there that's going away from us looks like it's going straight down. It's probably, let's say, 20 or 30 miles away. That couldn't be more than, what, 400 or 500 foot of drop if we lived on a ball. So that's proof that it's perspective. It's not earth curve. Jaron calls it the personal atmospheric dome, which I guess is as good a term as any, but he's right. It's observer dependent. And the farther, like I said, the further away something gets, the more it gives off that appearance. So it's perspective and whatever else is going on in the atmosphere. But it can't be earth curve, or we'd live on a tiny ball. So I've heard somebody say, like, our eyes are round, the earth is not. And that makes a lot of sense if you think about it. But even if the earth were a globe the way they describe it, that would not be enough to explain or justify the domed appearance we see. It does not do anything to prove earth curve. Like that plane there, one's flying toward us, one's flying against us. So I recommend anybody who hadn't already to pick a clear day without too many clouds and just go look at the jet trails for 10 or 20 minutes. And it will teach you a lot about perspective. And it'll help you understand the flat earth and the way our eyes work.
Hopefully now you can see pretty much all of Chicago,
see all the lower buildings,
including what's at ground level.
So the atmosphere really is acting like a lens.
Yes.
So the atmosphere really is acting like a lens. According to the experts, say the bottom of this little stand here represents the bottom of the clouds. And so as you can see here, the light is way above, it's well above what would be the bottom of the clouds in this example. So let's see what happens. I turned off the lights and set my iPhone to record, and I'm showing myself here recording all of this with another camera, and I pulled the light back on the table, and watch what happens here. Ooh, check it out. And there's that refraction taking place again. It's got the light. It made the sun set, first of all, below the horizon in this case. And let's just show this. And the platform represents the bottom of the clouds, so the sun's going down, and oop, there it is. The bottom of the clouds, illuminated by a light source that's well above the clouds.
But for anybody who hadn't seen it, with just atmospheric lensing or magnification, you have the sun dropping and setting and not changing size. So I thought we were going to keep this honest, but you see the sun setting right in front of the camera, not change size on a flat earth. There's two ways that can happen, dude. With just cold air, with just a little magnification in the atmosphere, You know, I see where this thing's going already, man. So I'm gonna act accordingly, man.
So then you're saying that the sun is literally on the ground? Because in this demonstration, the sun, your analog sun is literally on the ground here. So you're saying that the sun is literally touching the ground in reality?
Nope. Did the sun touch the ground? Did the sun touch the ground in either example?
Yeah, and your analog is right on the ground there. So okay.
No, I'm saying did it actually touch the ground though in either example?
Yeah, it sure looked like it was.
Did it reach zero when it was just sitting above the ground in front of the camera?
I mean, it looked like your analog setup that you had there had the sun right on the ground.
Did it ever hit zero?
Did whatever hit zero? Did whatever hit zero?
Did either example approach zero?
Did what approach zero?
The sun example, the white light in the first video, or the picture of the sun, or the flashlight in the second video. Did either of them touch the ground or zero? The horizon is zero.
Yeah, it sure looked like you had placed the light, or whoever had done it, had placed the light right on the ground.
Like it, yeah. But it didn't though, right? It didn't though, but it did disappear though, right?
Yeah, so what I'm getting is that you think that the sun is literally basically right on the ground for flat Earth. That's what I'm getting.
What I'm getting is that the sun right in front of your direct line of sight disappeared. There's two examples of how it could work on a flat Earth, plain as day, without the size changing.
Here is for flat Earth. I don't know how this works, but that's quite amazing. That's how I think you're going to have to explain it.
We're off to a bumpy start because I just showed you in the first video with just a little bit of lensing, like they say, the atmosphere of the lens, backed the sun away, it disappeared, and it hit the bottom of the cloud.
So you think? So how high is the cloud? How high did you measure the sun to be?
So I can demonstrate something, and in the same debate, you pretend you didn't even see it.
So this object here, if you're above it, it can never ever obscure anything greater than its height. If you're above it, no matter how far or how close it is, or how far away it is, it can never ever obscure more than the height of the object. If you're above it, that's why.
It's critical to remember that things below true level will never appear above true level, and things above true level will never appear below true level.
So you tell me this boat is not missing more than whatever this is, 5 foot?
No, it is missing more because the Earth is curved.
This boat might be maybe 2 miles away, bro. And I'm higher than that. I'm like 15 foot high, bro. This is not more than 2 or 3 miles, and I'm a lot higher than 6 foot over the water, Trumpus. So the horizon, that boat is not behind the horizon, and this wave is, say, 5 foot, exaggerating, it might be 3 foot. It's going to block a lot. I mean, it's going to kind of a second wave, and on another boat, it's going to be blocked a lot. On orthographic view, you got a point, Rumpus, but when you look in through a first-person point of view, I give this to Randy, for example. He's got, it's here, visual. Look at this boat, how much is going to be hidden by
well, so you're saying exactly what we're saying, which is on a curved surface, it would do that because the line to the boat is underneath your line of sight.
This boat is not behind the curve because I'm a lot higher than the horizon should dictate for this boat to be behind it. I hope I didn't lose.
You think that's 2 miles away?
Yeah, Jose films it a lot, so he kind of knows his location.
Right, that's gone. That building's gone, isn't it? And that building's must have at least one story on it. Yeah. I don't know how big those waves are, but they don't look huge.
No, they're not huge.
What would you think if you took an auto level out and looked through the scope and say 30 miles away, you still had obviously a water horizon, but the auto level scope is below the water horizon? What would you think of that?
I doubt that it ever would be.
Well, about 5-6 foot it was, actually.
Yeah, and I would not question it at all.
You're saying the horizon is below the horizontal, which is what you'd expect.
No,
he said the crosshairs of the auto level was below the horizon.
It's critical to remember that things below true level will never appear above true level. And
oh, right. Oh, okay. Sorry. Right. Okay, that is a bit weird. Yes.
Yeah.
Okay.
Threw us off completely. It's really weird to me to think that you're 6 foot off the water or so, and that you can have a level scope and look through the scope, and basically the Great Salt Lake has been, loomed up a good amount. I mean, it really doesn't make sense to my mind, truthfully. It's looming up if the water's looming up, and it's covering part of the mountain. Like it threw me for a loop, really.
So how would you explain in your model, what would it take for the crosshair to block half a mountain and appear below the water horizon as exampled by myself and by George Notchek's Ice Lake measurement, and by Jessica Kozlowski and Tim Osmond's Great Salt Lake Strong's Knob measurements at like 7 foot above the Great Salt Lake. So it's not that rare. But how does the globe model explain that?
I'm not familiar with your particular example. I have seen George Natchik's thing. So I have seen George Natchik's thing. So you're saying, what you're asking is, how is it that if you're several feet above the water, that the crosshairs can be below the horizon? No, yeah. So the way, when light goes through a gradient, pressure or temperature gradient, it curves, and that curve has a radius. If that radius is larger than the radius of the Earth, then it will make something appear slightly higher. If that radius is smaller than the radius of the Earth, then it can cause distant objects to appear higher, significantly higher. So, for example, the horizon can appear higher. Then it can cause distant objects to appear higher, significantly higher. So, for example, the horizon can appear higher